Hello, I'm Asiya Gonzalez. I'm a senior researcher at Talc Research Center. I'm working on natural language processing and, in particular, in machine translation evaluation. In this part of the course, I'm going to present you the Asiya platform, which are its main functionalities, and the modules that constitute the overall Asiya platform. So the Asiya platform has been built incrementally during the last years, and it's under constant development and improvement. The core toolkit of Asiya was initially released in 2009, and several extensions have appeared since then in order to help MT developers in all aspects of their system evaluations and comparison. In order to ease the use of the Asiya toolkit, we provide some visual information related to the evaluation and the quality of the translations. There are three different online tools. The first one is the Asiya online interface that provides a graphical interface intended to allow users to familiarize with the functionalities of Asiya and to analyze real data sets in a graphical and interactive environment. This online interface favors the rapid development of data sets and evaluation of the systems. On the other side, the Asiya web service is a RESTful web service that allows to access to a remote instance of Asiya that is, moreover, running a grid cluster that allows to run several instances of Asiya in a very powerful environment. This is in line with today's cloud computing services, and it is intended to facilitate the remote usage of Asiya without downloading and locally installing all the modules. And finally, the Desert tool is a complementary tool for translation analysis and error analysis of the output of the translations. This tool was especially designed to allow developers to alleviate the burden of manually looking at the translations and their quality. So let's see in what is the Asiya toolkit. This is an open source command line toolkit. It is the core of the system and provides a calculation of the automatic measures. The most recent development of Asiya contains an extended version of linguistic measures for English and for Spanish, and some other metrics for other languages as well, and quality estimation measures. It also provides some mechanisms to perform some meta-evaluations. So this is the evaluation of the goodness of the measures. And it provides also some learning schemes in order to learn models that learn how to combine different measures. The repository of the Asiya toolkit contains more than 800 metric variants for MT evaluation. This includes the last version of most popular measures like BLEU and Meteor, and also some in-house ones. These metrics assess the quality of automatic translations comparing to a reference translation, and they can rely on different similarity principles like precision, recall, overlap, and matching. And they operate at different linguistic levels, since from lexical level to syntactic, semantics, and also discourse level. The unique requirement in order to to obtain all these measures is the need of linguistic processors for some of them for its possible target language. The most recent implementation of Asiya includes some linguistic resources for English, Catalan, Czech, Russian, French, Deutsch, and Hindi at different levels of coverage. So here you can get an idea of the number of measures that Asiya contains. These are all the measures available for English into Spanish translations. And here there are some measures that are general, like BLEU and Meteor and also NIST, and some others that look at concrete aspects of the translation, like how the verb has been translated, or how many of the prepositions in the translation are also present in the reference on the candidate translation. How can we use Asiya? So Asiya operates over test beds or test suites. What is a test bed? This is a collection of of segments in the source language. Then we have a collection of candidate translations, probably generated by different systems. And then we can have one or more reference translations normally written by humans. In order to run Asiya, the user must provide this testbed and a configuration file where you can specify which are the options you want to exploit the customized capabilities of Asiya. This configuration file contains just the input format of the files, which are the language pairs, and some other predefined sets of metric systems and reference and so on. But I think it's worth to show you a demo on how to run Asiya in your command line computer. In this demo, I will show you a very simple example of running Asiya with a very simple testbed. Let's see, first of all, what is the content of my testbed. I have a source file with the source segments, a reference file with the human translations, and a set of system files containing the segments obtained with automatic translators. Let's see what's the content of these files. The source sentence contains 3 set sentences in Spanish. The reference file contains 3 sentences in English, translated by a human. And the system segment files contains the 3 segments translated by the automatic online services. Now, let's see what's the content of my configuration file. The content of the the config file tells Asiya how to run, which are the parameters chosen by the user. First of all, we will tell Asiya that the input of my data is in plain text. Then we will tell Asiya that the source language is Spanish, the target language is English, and that we want to obtain the scores using the case insensitive mode. Then we will tell Asiya where to locate the files. Here I'm telling where is the source file, where is the reference file, and where is the location of the system files. And finally, we can also tell Asiya some optional parameters. In this case, I'm telling Asiya that I want to create a subset of measures called submetrics, and that this subset of measures will contain metrics BLEU, NIS, Meteor, and the lexical overlap. Actually, we can define any other subset of metrics at the choice of the user. And now, let's run Asiya. First of all, I will write the name of the program. Then I will tell Asiya that I want to do an evaluation, that we want to obtain the metric scores for each single measure. Then I will also tell Asiya that I want to obtain the scores at all granularity levels. This means I want to obtain the scores for the segments, but also for the at system level. Then I want to tell the Asiya which are the metrics that I want to obtain, and for this I will tell Asiya that I want to obtain the metrics I define it in the subset of some metrics. And finally, I tell Asiya where to find the config file. As a result, Asiya is displaying complete tables with scores. This table contains some lines with the system level scores, the document level scores, and here the rows containing the segment level scores for each segment, segment 1, segment 2, and segment 3. Each column contains the scores for each one of the metrics we defined. Here BLEU, the column for NIS, the column for Meteor, and the column for the lexical overlap. And then we see here in each row that we obtain the measures for each system in the config file. Here are the aperture lines, the bubble fish lines, the Bing lines with the scores, the reverso, and system ones. Asiya can obtain not only scores, automatic evaluation scores, but can also do some meta evaluation and learning, as you know. I'm showing here just some examples of what you can do. So, for instance, if we want to obtain a different set of metrics, we will tell Asiya the same, where we write the name of the program, the Asiya config, the name of a different metric set, and the eval single command. Then we can also perform some meta evaluation operations, telling Asiya where is the config file, that we're going to obtain a meta evaluation using the value for each single measure, but we're going to do this meta evaluation using the Pearson correlation, and we tell Asiya where to find some human assessments for the to compare the automatic measures against the human ones. Then we can also run an optimization operation where we obtain the measures for each single metric, and we optimize how to combine the scores of these measures. And this can be very useful to perform some learning operations in order to obtain models that will combine the measures for different measures. In this example, our learning method will be a perceptron, and in this way we can obtain a new measure based on the combination of previous one. That's all for